Let's take a trip back to grade school math class. Now some of you may be feeling like this, but if you're anything like me, you're feeling like this. Don't worry, I will try to make it as painless as possible. Now how many of you remember the formula y equals mx plus b? It's okay if you don't, because I'm going to go through it. Y is the dependent variable. So in the case of my project, this was length of service. X is the independent variable. So for this project, I looked at all the OSTOM scales as well as age, gender, and postal code. Finally, M and B are both constants in the formula, or numbers that are taken from the statistical output and used to find length of service. Following along so far? Good. Now you can confirm that you're pretty smart. Now that you understand where we want to go, we need to take the appropriate steps to get there. So how do we get from data to that beautiful formula we talked about earlier? Well, that plane that we took from North America to somewhere in the middle of Europe was conveniently called Stepwise Multiple Regression Airlines. Catchy, I know. While it sounds quite daunting, stepwise multiple regression is actually quite simple. Imagine that you're going to get an ice cream cone, and you already know that you want 3 scoops, one of vanilla, one of strawberry, and one of purple? But what are the factors causing you to want those particular flavors? Did you grow up going to get that certain combination of flavors with your grandpa every weekend? Have you been skimping out on your servings of fruit lately? Does your child really love one specific purple dinosaur? Whatever the reason, certain factors were included in your decision. In the case of the project, stepwise regression factored in all the independent variables to try to get a formula as close as possible to predicting length of service, which was already known, like the ice cream flavors. For example, for one of the samples in the study, the statistical output shows the resulting formula would be length of service equals negative 9.632 multiplied by the OSTOM score for domestic life managing resources impairment minus 7.749 multiplied by the OSTOM score for interpersonal interactions and relationships impairment plus 105.413. In simpler terms, that is y equals mx plus b. So after figuring out all the formulas and writing code for the tool, I ended up with something like this. It ended up looking pretty cool, but how does it work? Let's take Richard for example. Richard had a stroke and is now with ESD. He has a wife that is very involved in his care. The ESD team visited Richard and his wife in their home and rated him on the OSTOMs the next Friday at rounds. The tool predicted that Richard should spend 45 days with ESD. But how do we know that the tool actually works? A simple percent error calculation was used to determine the accuracy of the tool. Percent error equals predicted length of service minus actual length of service divided by predicted length of service. So in Richard's case, that means 45 minus 36 divided by 45, which equals 20% error or 80% accurate, which is what the tool is. So now that you understand how the tool was made, I was wondering if anybody has any questions.